Welcome to a really simple way to evaluate inverse trig functions. Inverse trig functions are not scary as long as you can remember these three definitions. And to help you out, I've drawn a picture of each of the domains. Now, where can you find this picture? If you go to the first module in Canvas, the Getting Started, at the bottom you'll see two documents, Unit Circle and Key, and Trig Identities and Key, and that picture is in the trig identities. You have all the trig identities you need to know, plus some inverse trig information that you do have to memorize. So let's go back and see how this works. Suppose we want to find y equals sine inverse of negative root 3 over 2. So the first thing we want to do is turn it around into a positive statement. That's the first statement in that red box there. We want to rewrite this as sine of y equals negative root 3 over 2. Okay, so now we're looking for an angle y whose sine is negative root 3 over 2. Now there are infinitely many of those. However, now we use the second part of that box. We need an angle y in between negative pi over 2 and pi over 2. Well, that cuts it down to exactly one answer. Y is negative pi over 3. That angle is down there, and it's got sine negative root 3 over 2. Now you might say, well, what about y equals 5 pi over 3? That also has sine negative root 3 over 2, and it also shares a terminal side with the angle negative pi over 3. However, the reason why that's not an answer is it's not in the interval from negative pi over 2 to pi over 2. So there's only one right answer. Okay, let's do another one. Y equals tangent inverse of negative 1. Again, I'm going to rewrite this as tangent of y equals negative 1. So now I'm looking for an angle whose tangent is negative 1. But not any angle. Y has to be, that means in, the interval from negative pi over 2 to pi over 2. It's the same as sine, except you're not including those two endpoints. Well, so we're down here in quadrant 4 since the tangent's negative, and that would be the angle y equals negative pi over 4. Again, 7 pi over 4 also has tangent negative 1, and it's in quadrant 4, but it's not in the right interval. So again, one right answer. Okay, and let's just do one more that's slightly different. Sine of cosine inverse of negative 1 over root 2. So let's start by just evaluating the inside. So let's look at this. Let's call that y. So y is cosine inverse of negative 1 over root 2. If you rationalize, that's the same as negative root 2 over 2. And so turn that around, cosine of y is negative root 2 over 2. And y can't be any angle. If we look up here at our pictures, y has to be an angle from 0 to pi. So we have to pick an angle between 0 and pi whose cosine is negative root 2 over 2. Well, that's this angle right here, 3 pi over 4. Y equals 3 pi over 4. So that's not quite our final answer, because remember, we wanted sine of y. So now we finish up the problem. Sine of y is sine of 3 pi over 4, and that's 1 over root 2. Or if you like to rationalize, root 2 over 2. Okay, and it's that easy.